a nightmare.
Activate.
Alright, so now we're going to move on to question number 2. It says the metabolism is a sum of all the chemical reactions in the cell of the bodies. One metabolic reaction is the formation of lipids. Give another metabolic reaction in cells. Well, for that you can go for anything from respiration, formation of proteins, breaking down of proteins. You can go for photosynthesis because it's not asking you specifically of animals, it's just saying cells. So you can also include plants in there, okay? Any of those will give you the marks. Okay, so the table 2 shows the mean metabolic rate of humans of different ages. So you have the ages here from 5, 15, 25, 35, and 45. You have the metabolic rate in kilojoules per meter square per hour. And then you have males and then you have the females, okay? So then it says, what 2 conclusions can be made from the data in table 2? Tick 2 boxes, and this is very important. Remember, it says tick 2 boxes. A lot of the time people just tick 1 box assuming that you only have to tick 1 box, and you're just losing marks like that, okay? So in this case, as age increases, the mean metabolic rate of males and females increases. So age is increasing, and is the metabolic rate increasing in all of them? No, it's actually decreasing. So definitely that's not going to be one of your answers. So by process of elimination, we know that that is definitely not one of the answers. Now we have a 50% chance of getting them right. Well, probably more. Now that we can have a look at the rest of them. It says males have a higher metabolic rate than females after 5 years of age. So after 15, males got 45, females have 42. And that definitely will be one of your answers, okay? That has to be one of your answers. So we're going to go for that. Then it says the mean metabolic rate of females decreases faster than males up to the age of 25 years old. So from here to down here, is the female decreasing faster than the males? So it's both started at 53. Which one went down faster? The female. Which one went down faster? The female. So I believe that this one here would also be your correct answer. But just so we can have a look at the other ones. It says the mean metabolic rate of males and females decreases more quickly after 35. After 35, it went down by 1. After 35, it stayed the same. So that is definitely not one of your answers. And then it says there is no relationship between the age and mean metabolic rate. Well, definitely there is, because as you change your age, your metabolic rates also change. So that is not a viable answer, okay? So there we go. That will be your 2 answers for that question, okay? Let's move on to the next part. Okay, so we got question 2.3. Calculate the percentage decrease in the mean metabolic rate of males between 5 to 45 years of age. Use the equation. Percentage decrease equals the decrease in metabolic rate, original metabolic rate times 100. Give your answer to 3 significant figures. And this is very important. It's asking you to do it to 3 significant figures. If you don't, you may lose marks for that, okay? All right, so let's have a look. Decrease in metabolic rate. So what is the decrease in metabolic rate? Let's have a look at the previous page. And we're looking at males between the years of 5 to 45 years old. So when the age of the male was 5, you had 53. So at 5 years old, you got 53. And at 45 years old, you got 37. So what you're going to do, you're going to do your 53 take away 36, sorry. 53 take away 36, and that's going to give you 17. So at the top of the equation, you want to write down 17, okay? So you got 17 divided by the original metabolic rate, which in the males was 53. And then you're going to multiply the whole thing times 100, okay? Now, as an answer, you're going to get 32.075472 and so on. But it's asking you to do it to 3 significant figures, okay? So you have to round that up, and your answer would be 32.1. All right. If you do not do the 3 significant figures, you will lose a mark for that. You get 1 mark for this and 1 mark for that, but you won't get anything for this. And if you don't show you're working out and your answer is correct, you can still get the 3 marks. But if you don't write down your working out and your answer is wrong, you definitely get no marks. So it's always so good to show your working out, regardless of how simple and easy it may look. Just write down your working out to get those extra marks, okay? Right, moving on to question 2.4. Regular exercise can increase metabolic rate. 2 people did 5 minutes of gentle exercise from rest. Table 3 shows the effect of exercise on their heart rate. So you have your time in minutes, that was at rest, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, person R, person S, and this is the heart rate going at those specific times, okay? It says the question 2.4. Describe 2 differences in the response of person R and person S to exercise. Use information from table 3. Now, because table 3 is here in bold, all right, they will be asking you, they will be expecting you to actually write down some figures or what you see in that table, okay? Okay, so the one thing that we can see here is that the person R, their heart rate rose or increased a lot slower than person S, right? Person S went from 78 to 100, 110, whilst person R was in 76, 85, and whatnot, okay? And that would have been one of your things. So, okay, and another thing that we can see there is that the heart rate of person R leveled off, whereas the person S continued to increase. So if you see after the 4 minutes, heart rate is leveled, whilst person S, the heart rate continues to increase. Let's go to questions 2.5. Complete the line graph in figure 3 for person S. You should add the scale to the x-axis and label the x-axis. So these two are a must, okay? These 2 things you definitely have to do in order to get those first 2 marks. And I imagine that the rest of the marks will be for plotting them correctly and doing your line of best fit or curve of best fit correctly, okay? So let's have a look. You have already been given person R, and what you don't have there is your x-axis, okay? So one side it says heart rate in beats per minute. So what will be the other axis? So heart rate in beats per minute. So the other axis has to be the time, because this is what is changing. This is your independent variable. All right, so that's going to be your time in minutes, and let's have a look at the timings. So it goes from 0 all the way to 5 minutes. So the highest number that we were gonna go to is 5 minutes. So let's have a look if it matches. So if we go to 0, 1, 2, 3, 4, and 5, easy peasy, right? Because remember person R level off at 4 and 5. So at minutes 4 and 5, the heart rate of person R was the same. And if we're there to do 4 and 5 down here respectively, then you're gonna have the same level there or so, okay? So we have 1 minute, 2 minutes, 3 minutes, 4 minutes, and 5 minutes. All right, that's 2 marks right there. Now the question says that you need to complete the line graph in figure 3 for person S. So when he was at rest, the heart rate was 78. So let's have a look for 78. So at 0, check this out. There we go. At 0, it was 78. Now, if we look at this, half of there will be 10. Okay, so that means that 1, 2, 3, 4, 5, every 5 little squares count as 2. Okay, every single one of those little squares counts as 2. So if we're looking for 78, we are gonna go all the way to the top here. That's 80. So halfway through should be 70. That should be 70. And if every single one of those squares is 2, we need 4 of those squares. So that'll be 1, 2, 3, 4. And that will be your 70, the 78 right there. Okay. So it would start at 78, because remember from 0 it was 78. That's the resting position. Now the next stop that we have is 100, 110. So at 1 minute it was 100. That would be pretty easy to get. At 1 minute would be 100. So there we go. Now when it comes to this, I like to use a ruler to make sure that my points are correctly plotted. For the 1 minute it was 100. So that this one is pretty fine though, because it's dead on the line. But some other occasions it's not very easy to follow. Sometimes you lose track. So, and then we got after 100 for the 2 minutes, we're looking at 110, then 119. Just try to remember that. So for the 2 minutes will be 110. Now when we look at this, so if that's 120, 110 will be dead in here in that line. 110. Now this one is easy as well. You just have to follow the line straight there. So that will be your 110. And then the other one was 119. Let's just have a quick look. Yeah, 119. Now for this one, it's going to be a bit tricky because it's an odd number, and as the squares are going up in 2s, you might find a little bit difficult to get it on the spot. Okay, so so if you got 119, 118 will be down there. So 119 will be half of that mark. Okay, so for this, you're going to use your ruler, and remember it's going to go to this line because this is the line of the 3. And if we go somewhere in the middle of it, the dot there, that's what your line should be. Okay, and then we have 129, I believe I saw 129, and then 132. So 29, where would 29 be? If it was going up in tens, 20, that would be 130. 129 will be at the halfway line as well. So again, we're gonna get that ruler so we can just make sure that we are hitting on point and we don't get confused along the line of tracing that line. Here we go. There you have it. And then the last one is 132. So if it's going up in 2s, the next square will be 32. So this is 130, 132 should be that one right there. Okay. Is it asking us to do a line of best fit, complete the line graph, shoot the scale, the y-axis? It's not really asking us, but it's always a curve of best fit. Okay, and I don't know why this is something that you're always gonna find, is that when it tells you to do a line of best fit, at least in science, if you can blatantly see the dots making a curve, you want to do a curve of best fit. You don't want to start doing one line that crosses through most points, because that's not what is being asked. Unless you have a specific just linear relationship, then yeah, you could do that. But normally you're gonna have to go a curve of best fit, something like that. Okay, that's what you want. All right, question number 2.6. After 5 minutes of exercise, the heart rate of person S was 132 beats per minute. When person S rested, his heart rate decreased steadily at a rate of 12 beats every minute. Calculate how much time it would have taken the heart rate of person S to return to his resting space, or to resting rate. All right, so this one here will be pretty easy. So we have a heartbeat of 132, and the heart rate was 78. So we do 132 minus 78. Okay, and then we're gonna divide that by the number of beats that it went down every minute. So this is gonna equal to 54 divided by 12, and when you make your division, you will get 4.5. All right, and you can say that it taken 4.5 minutes. Okay, so 4.5 minutes, or you could just say 4.5 minutes. There you go. That would be your answer for that one there. All right, so now we're going to go to question 2.7, which is the 6-mark question, and let's have a look what it got for us. Okay, it says a student made the following hypothesis about the heart rate of smokers and non-smokers during exercise. During exercise, the heart rate of smokers increases more than the heart rate of a non-smoker. Design an investigation that would allow you to test this hypothesis, and that would be a 6-mark question, okay? Now, for a level 3 answer, you got to make sure that the method would lead to a production of a valid outcome, and all key and steps are identified in a logical sequence. That is where you're gonna get your 5 marks and your 6 marks, okay? Okay, so for to start, you're gonna make sure that you have, it says that smokers increase. So basically you're gonna be putting smokers against non-smokers, okay? So the first step is to have 2 groups of people, of smokers and non-smokers. For the purpose of getting more data, you gotta make sure that the groups of people could be 5 or more. The more the better, okay? Then you wanna designate a specific exercise for everybody to do the during the experiment. So we can go for star jumps. We can say each person to do star jumps exercises. You want to make sure that you have some control variables in place, and that could be from having the same number of people, have them to have the same gender. You want to have them to have the same level of exercise activity, same age, no health issues of illnesses, and you want them to do the same exercise, and you want them to do it for the same amount of time as well, okay? Once the exercise is done, you want to record the heart rate of each person before and after the exercise. So not once it's done, but you want to record the heart rate before and after the exercise. Once you've done that, you're going to calculate the heart rate of each person after the exercise, and then you want to compare the results with each group. Okay, and there you have it. That will be your 6-mark questions covering everything that you need to know in order to get those 6 marks. Okay, so we're gonna continue with question number 3. So just click on the next video, and I'll see you then.
It was a nightmare. Activate.